Ambulatory Blood Pressure Monitoring System. Our project design is divided into two parts: to develop a prototype design for ambulatory blood pressure monitoring system, first being hardware, which we have designed from scratch, and second being the software, which comprises of the algorithm code for the hardware in embedded C. And for machine learning, we make use of Python. Let's look into the hardware design, where we have tried to design a prototype. As you can see, our design has an Arduino microcontroller unit at its heart, which uses other peripherals for sensory movement to get the data for ambulatory blood pressure monitoring. Then this data is sent on the cloud server for further utilization. Our design uses oscillometric method to measure the blood pressure. In the oscillometric method, we make use of a cuff that is inflated by an air pump, and then the pressure is sensed by an air pressure sensor. We use the MPX 2050 GP. We have also designed an amplifier and filter circuit which was simulated on Proteus. To control the mechanism of inflation and deflation of cuff, we use an air pump and solenoid valve, respectively. For data transfer, we make use of a GSM or a 2G network which transmits data on the cloud using a GSM module for Arduino, which is called as SIM900A. This completes our hardware model.
The next step is wireless network communication. To enable this, we use a GSM SIM900A module interfaced to the Arduino Uno, and using IoT, we will send the obtained pressure sensor data onto a cloud platform called ThinkSpeak. So in the code, we can see that the first step is to establish a serial monitoring connection on the Arduino to ensure that the microcontroller and the GSM module is on the same baud rate. That is, in our case, the baud rate should be 9600. The obtained pressure sensor value is stored in a variable called pressure value. To push this value onto the cloud server, we need to establish a network, that is in our case a GSM 2G network. To establish this network, we make use of AT commands which are used to establish network using cellular device. After all the necessary commands are called, an APN is set up to enable cellular connection. In our case, we are using an IDEA SIM card, thus the APN for IDEA is called as Internet. Next step is we set the network to obtain the IP address, and finally we have inserted the API write key of ThinkSpeak so that the data coming from MCU gets displayed on the cloud server. This is the code being executed and sent to display on ThinkSpeak. The data which is sent by GSM is displayed in a graphical manner on ThinkSpeak. The pressure readings are in unit called PSI and the time is in seconds. After every 6 seconds, the pressure sensor gives the pressure reading.
Moving on to the machine learning part, we have used machine learning in our project for prediction purposes. Now as we see on the screen, the necessary files are loaded. One is the Rohit and the other two files are the data sets. Now the patient's data is loaded into the program. Here we can see the numerical representation of Rohit.csv. As we move forward to the next cell, we can see a graphical representation of Rohit.csv. In the next set, we load the dataset required to train the model. The model which we have used here is decision tree classifier, and it classifies the patient into different blood pressure diseases. We have used the legends, namely normal is labeled as 0, hypertension has 3 cases in which we have labeled elevated as 1, risk as 2 and crisis as 3. Hypertension is labeled as 4. This is the part where the mail gets sent to the doctor. COC boy of 99 is a sender email and valenidisilva@gmail.com is the receiver's email. The scripts uses COC boy of 99 to send email to valenidisilva@gmail.com, and in this mail the output of the patient is sent. In this case, the patient's data will be sent as average because Rohit.csv contains all the values of that of a normal patient. Now in order to evaluate our model, we have used two measures. One is mean square error and other one is confusion matrix. If you see at the mean square error is 0.00%. That means our model performance is based on training data and the testing data. Also, if you take a look at the confusion matrix, then the confusion matrix is ideal. That is, we get all diagonal element. Here in this case, there are no misclassification.
For the second part of the machine learning model, we have considered the risk of cardiovascular disease. The model predicts the risk of an individual developing cardiovascular diseases based off various habits and factors, which add to the risk. The factors we have considered are cholesterol, diabetes, gender, smoking, and alcohol consumption. The doctor types in the data of the patient at a remote server. If an individual has a factor that will increase the risk, it will be denoted as a 1 in the dataset. If the factor does not add to the risk, it will be denoted as a 0. Here in this cell, we have imported the training set into the script. Below is a process similar to the previous model, but here we use linear regression for a more efficient prediction. The model is then trained to fit our data, and the patient data is passed through the model. Finally, we get the output stating whether the risk is high or low. To evaluate the accuracy of our model, we have used root mean square error method, which outputs that the error is minimal.
Here we can see the automatic email which is generated by the Python script. cocboy99 at gmail.com is the email ID the Python script is using to send the emails. The email gives a brief information to the doctor about the patient's BP condition, thereby reducing the doctor's workload of personally going and checking the patient's BP condition. Thank you.